Okay, so what's the probability that zi and zj get compared? So let's consider any section of the array. So this is not contiguous. So these are not contiguous in the array. They could be scattered all over the place. So for example, here's zi, here's zi plus 1, here's zi plus 2, here's zi plus 3, all the way up to zj. So those are the elements we're going to look at. What can you tell me about this group of numbers? Well, what you should be able to tell me is that if none of these are chosen as pivot, so let's say that this value here gets chosen as a pivot, all of those values get passed to the same recursive call. Because the value that we chose was either, as pivot, was either greater than zj, or it was less than zi. So it's one of these other values, and it's less than zi or greater than zj, which means all of zi through zj get passed to the same recursive call. So given that, we only need to consider the case where one of them is chosen as pivot. Because for all other cases, they get passed to the same recursive call together, and we only need to consider the case where something in this range gets selected. Okay, so looking at just the values in that range, so in particular, we're going to have I is equal to 3 and j is equal to 7. What's the probability that z3 and z7 get compared? And I'm specifically asking for this array here. So what's the probability that we compare 37 with 79? What's the probability that we compare those two values? Okay, well, like I said, we only compare them if we select those two values. So if I select 37, so z3, then they get compared, or if I select 79, so z7, they get compared. So that's two values. How many values could I select where they don't get compared? Well, they don't get compared if I select a value between them, because that would put them in separate recursive calls, which means they never sort of get joined back together. So how many values are there when you include them and everything between them? Well, you have z3, z4, z5, z6, and z7. So that's 1, 2, 3, 4, 5. So they have a 2/5 chance of being compared. So a 2/5 chance of one of them being selected as pivot before something between them gets selected as pivot. So let me try to be a little more specific about that. Among all these values, consider the first one in this range to get chosen. Well, if zi or zj are chosen, then they get compared. One of them is the pivot value, and we always compare everything in the subarray to the pivot value. If something in between them gets chosen, then zi and zj are never compared. Why is that? Because if we choose something between them, then if one of them's chosen, then they get compared directly. If we choose something in the middle, then they go to separate recursive calls, and they never get included in the same call to partition. So more generally, what do we have as an equation for the probability that we compare any two numbers? Well, we could grab out one of those two numbers out of the entire range of numbers that they are. So we ignore everything, ignore greater than j, and ignore less than I, because for those values, they get passed on the same recursive call. It only matters if we pick something in between or if we pick one of those two values. So what does this mean for values that are close to each other? Well, for values that are close to each other, that means that I and j are two values that are close to each other, which means we would have a smaller number in the denominator. So this is a higher chance that we compare them. For two values that are far apart, that's a lower chance that we compare them, which makes sense. So what's the probability that we compare the minimum value? So if you look at all values in the array, let's say that this is already the sorted version. What's the probability that we compare the minimum to the maximum? Well, one of them has to be chosen the very first time, so that's a 2 in n chance. because if you pick something else, they're guaranteed to go to separate recursive calls because they're going to be in different partitions. All right, so how do we count the number of comparisons? This will be where we pick up in the final video for Quicksort.